The phenomenon of excessive heat on Earth can indeed be attributed to a combination of human activities and natural cycles, but understanding the relative contributions of each is key. Greenhouse gas emissions. Human activities, particularly the burning of fossil fuels for energy, industrial processes, and transportation, release greenhouse gases such as carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O, into the atmosphere. These gases trap heat, leading to a warming effect known as the greenhouse effect. Deforestation. The clearing of forests for agriculture, urbanization, and other purposes reduces the Earth's capacity to absorb CO2 from the atmosphere, contributing to higher levels of greenhouse gases. Urbanization. The expansion of cities with materials like concrete and asphalt, which absorb and retain heat, known as the urban heat island effect, can locally raise temperatures. Natural cycles. Solar variability. The sun's energy output fluctuates over long periods, which can influence Earth's climate. However, these changes typically occur over thousands to millions of years and are not significant factors in the rapid warming observed in recent decades. Milankovitch cycles. These are cyclical changes in Earth's orbit and axial tilt that occur over tens of thousands to hundreds of thousands of years. They influence long-term climate patterns such as ice ages and interglacial periods, but are unlikely to be responsible for the rapid warming observed in recent decades. So, while natural factors certainly play a role in Earth's climate, the overwhelming scientific consensus is that the current trend of excessive heat is primarily driven by human activities, particularly the emission of greenhouse gases. The evidence supporting this conclusion comes from diverse sources, including direct measurements of atmospheric CO2 concentrations, the isotopic signature of carbon in the atmosphere, and sophisticated climate models that incorporate various natural and human-induced factors. Addressing excessive heat and mitigating its impacts will require concerted efforts to reduce greenhouse gas emissions, transition to renewable energy sources, protect and restore natural carbon sinks like forests and wetlands, and adapt to the changes that are already underway.